All right, so I'm going to try something a little bit different this time. I'm not using high definition. Maybe it'll be better. So I look more blurry, but that's okay. All right, so today is February 7th, ITS148, and we're starting Chapter 7, it looks like. So let me share my screen. Share my screen. Am I sharing my screen? Oh. Yeah, I must be sharing my screen. Let me move this over here. Let me put this down, and it looks like I'm sharing my screen. I hope this all works. And am I recording? I think I'm recording. Okay. All right. So today is February 7th. So we are right here starting Chapter 7. And so Chapter 7 is exception handlers and data validation. You guys know about exception handlers and already. If data validation is a topic unto itself. Exception handlers are good to use if we are as a quick and dirty way of keeping control of your program without it bombing. With these newfangled object-oriented programming languages that include exception handling as an option, we can always avoid program bombing. Back in the old days, it wasn't that way. But exception handlers is kind of the quick and dirty way of handling these exceptions. It's better usually if your program is actually smart enough to check the data, programmatically to make sure that you're entering in the right stuff, that the user is entering in data properly, and other things. Back in the old days, that was the only way to keep control over your program. But exceptions can still occur. It's oftentimes, especially with larger complex programs, you can't expect to catch all exceptions. So let's start with the PowerPoint slides, and we are in Chapter 7 already. So let's open this up. Let me save it, and I'm going to save it on this computer, I guess. Be down here, and let me find it now. Let's see, here, here, here. All right, how to handle exceptions and validate data. 38 slides. In this chapter, we're gonna given a form that uses text boxes to accept data from the user, write code that catches exceptions that might occur, and then we're also going to learn about validating user entries, which is a little bit different way of handling it. It's probably a better way. And we're going to use dialog boxes to alert the user when inputs are not correct. And as far as knowledge goes, we'll be able to explain what an exception is and what it means for an exception to be thrown and handled. Describe the exception hierarchy and subclasses, and describe the use of try-catch statements to catch specific exceptions as well as, all exceptions. And we'll also learn how to throw our own exception. And we'll learn to describe the use of properties and methods of an exception object, describe the use of the throw statement, describe 3 types of data validation that you're most likely to perform on a user entry, and describe 2 ways that you can use generic validation methods in a method that validates all the user entries for a form. So if you don't handle your exceptions, then if the user types in something that the computer doesn't like, or that the C# runtime machine doesn't like, then it as we say, bombs. And when it bombs, it doesn't just go out to lunch. It doesn't just stop or whatever. The runtime machine flashes up what the problem was, and it says an exception handled, an exception occurred, and it was unhandled. In other words, the programmer did not handle it. There's different kinds of exceptions, of course. It says what kind of exception it is, usually at the top. In this case, in this example shown here, as we can see, it occurs on a convert to decimal method call, where somebody must have typed into this text box here, txt monthlyinvestment.text. This is the future value program, and somebody types in a monthly investment. It should be a decimal value, and it's got some characters in there that make it so it doesn't look like a decimal number, and then so the computer just stops and throws up this exception. And it tells you some other stuff here. It tells you the type, the unhandled exception type. It's a system.formatException type exception. And it also gives you some troubleshooting tips, and some other things that it does is it can give you a stack trace. A stack trace is the calling sequence, or the series of method calls that brought us down to where the exception occurs. Excuse me, my phone thinks I'm talking to it. Stupid phone. All right, so so what we're going to do here is we're going to learn how to write code. Well, you already know probably, but we're going to learn how to write code to, quote, handle this exception. In which case, your program still is in control. It just it was just alerted by the runtime machine that something's funny here, so you can handle it. So it passes it back to the programmer, the program to handle it instead of just stopping. There's an exception hierarchy, and so these are 5 common exceptions that we see. There's in the exception namespace, or in the group of so-called exceptions, we have format exceptions and we have arithmetic exceptions. So format exceptions are recognized, if you want to think of it this way, are recognized at a higher level, or maybe at a different place than arithmetic exceptions. So format exceptions are things like, the user types in some letters and the program is expecting some digits. So that's the the software that supports C#. There's a underlying method that attempts to do the data conversion. It takes the string of characters and and does operations on the string of characters. It's still just a plain old method, and the error checking, there's actual error checking going on, and it's a program. It's usually an operating systems program. It's not something you write, but it's something that the systems programmer writes. The systems programmer that's writing the C# runtime machine, as we call it. And when we're converting a string of characters into an actual numeric value, it looks at one character at a time, and each time it looks, it's expecting a character that's in between 0 and 9, or possibly a period. And if it doesn't find, and you know, the program is able to check the range. It's the character. It's a simple character, and the program is able to check the range, or check check the character and compare it to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, period. It's able to compare, and if it's not one of those, then that program says, whoa, 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 and it throws an exception. It throws an exception, just like when you write your code to throw an exception, which we'll learn in this chapter. It's the same thing. So it's a program that's throwing an exception. Now that's different than an arithmetic expression, an arithmetic exception. An arithmetic exception is handled down at the microprocessor level. It's hardware. The hardware is chugging along, and you give it the first, you know, you give it a dividend. You give it a dividend, say 5, and then you give it a divisor named like a 0, and the microprocessor actually goes forward and tries to do it, and the microprocessor has hardware in there that says, whoa, this number is getting too big. This number is too big, or this number doesn't work. And then the hardware throws an exception, and what it probably does is it causes what's called an interrupt down in the microprocessor, and it vectors off to some other code that's in the microprocessor to pass up to the operating system that this divide by 0 caught by the microprocessor has occurred. Same with an overflow exception. You're doing some calculation, and the microprocessor is calculating away, and then all of a sudden it does a calculation, and the result is too big for where the programmer is telling it to put the result. There's not enough room. So the microprocessor says, whoa, 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 I can't do this, and we'll vector the code off to some other microprocessor code, which makes it way back up to the operating system, and the operating system takes that and goes, whoa, this is an exception by the microprocessor. It's an arithmetic expression, and then it throws the exception, which the programmer can ultimately write code to handle. So those are a couple different kinds of exceptions, and these are the kinds of these are some methods, some built-in methods that may throw exceptions. Here we're converting some string of digit characters, or perhaps and perhaps a period character, you know, within the string of digit characters, and if it encounters a character that's not a digit character or a period character, or perhaps it's the second period character in the string, that's wrong. But it's a program that's written by some systems level programmer. To the programmer, you know, back at Microsoft, the programmer that's writing the convert.toDecimal method, that will get built into C#, that will get added to the .NET framework. That programmer writes that code to throw an exception. that would be the format exception. Now an overflow exception could be something that the microprocessor would throw because the programmer's code is going along processing these digit characters, and it keeps on going, and all of a sudden it goes too far, and it's adding, multiplying, adding, multiplying. When you're converting a string of digit characters into the actual binary number representation for that number, it's doing a looping, convert the digit character to the digit value, and then adding it to a sum, and then multiplying that sum by 10, and then adding the next digit and multiplying that by 10, and adding the next digit and multiplying that by 10. Keeps on going until it ends. And if it keeps on going too far, inside the microprocessor, the number is going to get too big, and then it throws this overflow exception. And it can be caused by a convert to a 32-bit integer. It can happen with when you're parsing a decimal.parse. Can happen date-time.parse. You're parsing a date, and somebody says, well, it's the 13th month. It's the 32nd day of the 13th month. That would be a format exception. Or actually, a format exception would be you have a date time, and you're expecting a certain set of characters, and you get something that's not expected. The first example I used would not be an example of that. All right, so we're reminded of how message boxes work. The message box class, the show method of the message box class. This is just reminding us of that. Mentioning that there is this optional caption field. The caption field appears up here, right here. So this text, which is what we're used to using, and in the past, that's all we've done, is done the text. That's what displays out here, this big, long message here. But if we want to put something up at the top of the dialog box here, that would be a caption. So, for example, this particular error message dialog box is produced by using this statement here, where you have message box.show, and then the please enter a valid number for the subtotal field. That's what you see here in the message. And this entry error is the caption, the optional caption, which appears up at the top here. We've seen this before. This is the syntax for a simple try-catch statement, and that's how you catch exceptions. Generically, you can do a bunch of, you put a bunch of statements that you want to execute in the try block of the try-catch, and it's a bunch of statements that can cause format exceptions or arithmetic exceptions. And as long as everything goes fine, it goes merrily along its way. When it's done, it skips over the catch part and continues on down below. If something goes wrong within the try part, some exception occurs. If you do something, if the user, it's usually the user who does something wrong, it can be your program also. I mean, you could have a logical error in your program, or some logical error where your expression is wrong, or you forget some parentheses or something, and you accidentally do, you go along and it works fine through all your tests and everything, but maybe you forget to test something. It's out there in the field, and something happens, and you end up dividing by 0. You know, that could cause an exception, and then so the catch part would catch it. Once the statement that caused the error is attempted to be executed, if this exception occurs, then it jumps right into the top of the catch block and executes the catch block, and then it continues. And so in the catch block, you usually have some kind of error message. And this would be an example of a dialog box that would occur if somebody types in this. This is the invoice total program that we've been messing with. Somebody types in something into the subtotal that's not a number, and your try catch or your exception handler can display out an error message which looks like this. So the syntax for a try catch statement, the syntax for a try catch statement that accesses the exception would look like this. And so in the catch part, you may want to know, there in the try part, there could be, a bunch of different statements, and there could be a bunch of statements that cause different kinds of exceptions. And so, it's for convenience, you may want to put a bunch of statements in one try block, and then whatever caused, okay, so then if an exception occurs, you would like to know what kind of exception it is. It's more to know. It's more than wanting to know which statement caused the exception. Because a particular statement can cause more than one different kind of exception. So you're able to access this particular, or you're able to access a particular type of exception through a name, through an object. And so the catch, what's in the argument, or the argument for the catch clause can declare an object, and the type of the object is an exception class. That's what this exception class is. And you want to name it. You want to name it so you can have something to refer to. And so it passes up to you this object. It's an exception class object with a name. And in this example, the name is called exception name. And then in this block of statements, you can refer to the different properties that this exception name object has. And there's two properties in a method that we're going to use or be concerned with. One property is called message, and that message contains a message which briefly describes what the exception is. There's another property which is a big long string called stack trace, and stack trace provides a string or a bunch of text that lists the methods that were called before the exception occurs. So, in your program, your program is really a bunch of nested method calls. It starts out at the very top of the operating system. The operating system is there, and the user, you being the user, will type the little go button or the button, whatever, that starts your program. And then the operating system calls your program, and your program is like one big huge method, or it's actually an object, and you call it. And so there we have the operating system calling your program, and then your program is executing away, and it's calling its own methods. And you know, methods can call methods can call methods, and then an exception occurs, you know, way down there. And what this stack trace does is it traces back, so it lists all the names of the methods that led it to where the exception occurred. So so you know, you could have some sort of general try catch someplace. Oh, it's also possible that your try catch is, you know, like way up at a higher level, but in the try block you're calling a bunch of methods which call methods which call methods, and then way down below some exception occurs, and you don't bother putting try catches way down below, so it can pop up to, you know, it pops up to where there is a try catch, or to where there is a catch, and you can see that trace in the string. That might not have made a lot of sense, but we'll understand what I was trying to say in a moment. There's another method that you can call which will get the type of the current exception, and that'll tell you if it's a divide by zero exception, or an overflow exception, or a formatting exception. So with especially message and get type, you can give the user a lot of information on what it was that caused the exception. So here's a try catch statement that accesses the exception. So we have this try portion here that's trying to convert something that the user typed in into a decimal number that can be stored into this subtotal decimal typed variable. And the user types something in wrong, and an exception occurs, so it plops down into this catch part. And so here we've declared an object, or a variable, an object called EX, and it is an exception type of object, or it's an object that is an instance of the exception class. And then so in your code you can refer to the properties and methods of this EX object by, you know, ex.stacktrace, ex.message, or ex.getType paren and paren. And so this message box is first going to display the message with 2 returns. That may or may not work. You may have to put /r's in there, I'm not sure. We'll see. Followed by the type of exception, and you put toString because, you know, you want to convert it to a string type. It could be some other representation, but this will convert it into something that you can display out. And then the actual tracing of the method calls down to the exception. And so in the case of converting a character string that was typed in by the user to the, you know, user types in something wrong, an exception occurs, and this message box.show is executed, and this is what it may display. And so first of all, the message is input string was not in a correct format, and then the get type, the string, the message, the exception type would be system format system exception format, that would be the exception, the name of the exception type. It's a format exception. It's a format exception. And then this is the stack trace. So it's at system number dot string to number string. So this system dot number dot string to number, that's a method that is provided for you in the .NET class. So it's a system dot. So string to number was what the programmer that wrote that string to number method. That's what that programmer chose to name that method. It's called string to number, and these were the arguments or the parameters that were given to the string to number. It was a string, whatever this other stuff is, and parse decimal. So this is sort of the stack, popping the stack down to, let's see, I guess it's back up to the button calculate method, the button calculate event handler. So at the top level, we see it's the button calculate event handler, object sender args in this C# 2015 invoice total form.cs line. So it's all the way back up to the line, the C# line of code in form 1, in form1.cs, that line, which is where you will find calculate underscore click, the button calculate underscore click event handler, inside of which you'll find a 2 decimal, which is this, convert to decimal. And down within 2 decimal, you'll find these methods that are provided for you in the .NET framework. So it's a lot of information that you probably don't really need, and you probably would not pass along to the user. If your program is in production, it's being used. If anything, you would display out the message, but you probably would not even display out system.format exception, because that's meaningless to the user. But it's not meaningless to the programmer. So these would be, debugging features. Hopefully you will get all those bugs out of your program before you turn it over to users. And so when we're using exception handlers to handle these errors, you probably would rely on the message that is this message that's provided by the exception handler. And the idea is, in the second half of this chapter, you probably wouldn't even be using exception handlers. You'd probably be doing data validation, which is how we used to have to do it before there were exception handlers. Now, you can have multiple catches, have multiple catch statements, and and the idea here is that it's an order in which you want to check to see, or it's the order in which you want to look to try to identify precisely what the exception was. And so you may start with well, if this was a divide by 0 exception, that's the worst thing. So I'm going to check that first. It could be something else, but I'm going to check that first. If it's not that, it could be something less specific. And so then you can check that next. And so you can have these various catch statements. And so the first catch statement that applies the statements within that catch block will be executed, and then the rest of them are. And then if there's catches below that, those are skipped. This finally block, we may or may not have seen that before. That is in there, and that code is executed whether that code is always executed after whichever block of code is executed here. And so it's sort of you can wrap stuff up there if you want to. Just give an exception, or give an example. All right, so yes, here's an example. The statement that catches two specific exceptions. So the reason you could have various kinds of catches is because you have a bunch of statements in here, each of which can cause a particular type of exception, and you might have a preference, or you might have an order in which you want to look to determine what kind of exception it was. And you may not have specific catch blocks for every single kind of exception that occurs. You may have catch blocks for specific kinds of exceptions that you want to look for, but then all the rest of them, they'll be in this last catch block, which will more or less catch all the rest of them. And that it's still a way. It's because you want to keep control over your program. You don't want your program to bomb. The program bombs, and then what happens? I mean, it could be a program which if it bombs, it takes some extraordinary effort to make it start up again. There might be a bunch of initialization that has to take place. It could take a while, and so you for sure don't want that, and so at the end, you want to have an overall catch that catches everything. And we see in this case it's for everything else, but then it displays out this error message so you can see exactly where it is, along with the type. So you can throw your own exceptions if you want to. And so you can kind of create your own exceptions. You can throw existing exceptions, and you may throw an exception when a method encounters a situation where it isn't able to complete a task. And it could even be your code. You could be writing a bunch of complicated code, and you come to a place where you're going, well, this is possible, but it's so unlikely, and it's I'm not going to worry about it. I'm just going to throw an exception and tell them, don't use that data. So, you may, it's something like, the person. So let's say it's a monthly investment program, and you're going to handle cases where somebody wants to invest up to, $1,000 a month, and then after that, you say, well, in the people that are going to use this program are never going to invest more than $1,000. Well, let's make it more realistic. People that use this program are never going to invest more than $5,000 a month. So, and besides that, a bunch of other weird stuff happens. So I'm just going to make that an exception. And so you in your program, you check if it's greater than 5,000, and if it is, you throw an exception. And you could have a bunch of things in that class. That can be that type of exception. It's just a general exception that you've defined to take care of all the cases that you are not expecting the program to have to handle, and maybe you've even told the user, don't, the program is not appropriate for these types of inputs, and so so you define an exception, and then if and then you have your program checks for those exceptions, and if it happens, you throw it. You use this throw statement. If you want to catch the exception, perform some processing, and then okay, so that's another reason why you may want to throw an exception. So you you catch an exception, do some processing, and then you throw another exception. So here's a method that throws an exception when an exceptional condition occurs. So you have where the monthly investment, let's say, is less than 0, and the interest rate is less than 0. Now the math works. You know, your equations work, your loops will work generally, but a monthly investment of less than 0, that's kind of like you're taking money out, I guess, or something. Well, you know, you say, well, that's crazy. So I'm just gonna, you know, throw an exception, and this is how I'm going to do it. Monthly interest rate of less than 0. It's actually possible. I've heard of cases where you have an interest rate of less than 0. I'm trying to think of it. Sometimes international monetary stuff. But you know, you say, well, I'm not going to deal with that case. So you decide to handle it by throwing an exception. Here's code that can throw an exception. So you have a decimal. You convert. This doesn't seem like a very good example. I think it's just a dumb example where you decide to throw an exception for no good reason. But anyway, this is the syntax of the throw exception statement. All right, so in this case, if there's a problem up here in the convert, then a regular old, you know, data format exception occurs, and it'll display that way here. If this convert to decimal works fine, the next statement that's executed is this throw a new exception. So that's going to cause an exception also. It's going to go down here into the catch section, catch block, but it'll indicate that the exception is going to be an unknown exception occurred instead of what happened before. And here's an example where you can rethrow the same exception, I guess. Here you're trying to do something, and the person enters in a format exception, and it actually comes down here into the catch statement, and it sets the focus back to the subtotal, and then it rethrows the exception. Not sure why we would do that, but okay. So the code for the future value application with exception handling. Okay, what does this look like now? This and this. Okay, so first we convert the monthly investment input, store that in monthly investment decimal variable. Then we grab the interest rate, store that in this interest rate variable. Then we convert the number of years into an integer and throw that into this years variable. And then we do this calculation to calculate the monthly interest rate from the yearly interest rate. Takes the yearly interest rate, which is and then it divides by 12 to make it monthly, and then it divides it by 100 to make it an actual percentage. Because when you do calculations, you want it to be a percentage. And then we also want to months, yeah, months equals years times 12. If it's 1 year, it equals 12 months. So we compute months because we have entered years, but we want to compute months. We want to do this calculation month by month, but we're asking the user to enter in the data, you know, by year. And then we do this calculation here where we're using our calculate future value method that's defined someplace else in the same class. Calculate future value, or it might not be in the same class. No, it is in the same class because it's where this is here. And these are the arguments passed, and it comes back future value, and then we take the future value that came back, convert it to a string that looks like money, store that into this text, looks like it's a text box, the text field of the text box, and then it puts the focus back to this monthly investment. Now, so you know, there's lots of things that could go wrong here. And so in our catch section, the first thing that we would look at is a format exception. If somebody types in something goofy, and you want to stop right there. It doesn't make sense to go any further because you can't calculate on something goofy. But if the person types in some actual digits and it did not cause a format exception, but maybe the user typed in some valid number, but it was too big, or the user just typed in digits, digit characters, but typed in way too many. That could cause an overflow exception. And so it's not a format exception. It passes format exception. It's overflow exception. It doesn't make any sense to put the overflow exception before the format exception because if it's a format exception, it would never get to the overflow exception because it wouldn't even get to the point where it would start to, well, actually that's not true, but if you think about it, it makes better sense to first look at the format exception because that would occur more likely before the overflow exception. If the overflow exception occurs, then there was no format exception in general. So you look for that second. But there could be some other kind of exception, like divide by zero exception, and you figure, okay, these are the two input problems, and so we will check specifically for those because we want to tell the user there's something wrong with what you're entering in. But after that, if something else funny happens, then we'll just catch them all here at the end and display out exactly what the C# runtime machine says was the exception. Code for the future value application continue. Okay, so this is this is the calculate future value method that was called back here. No, called here, calculate future value. So it's gotten through this one without an exception. It's gotten through this one without an exception. It's gotten through this years without an exception. It's gotten through this calculating the interest rate, or calculating the monthly interest rate without an exception. It's gotten past calculating the number of months for the number of years. It's gotten through that without an exception. And then we call this calculate future value method. And so down here, this is the calculate future value method. And there is some stuff going on in here. And it's possible that that something in here causes an exception to occur. I don't know, like an overflow or something. But there's no exception handler here, so it throws an exception. And then so it would be caught. So let's say it's an overflow error. I don't know, you put some numbers in there that are so big, and you're doing this month by month calculation. You know, you put in, you know, a big humongous number for, you put in a big humongous number for the monthly investment, but it doesn't cause an overflow. Just in the conversion of what the guy typed in to storing it into the monthly investment decimal value, it doesn't cause an overflow. It's a big humongous number, but it doesn't cause an overflow. The guy types in an interest rate, that's a big humongous interest rate, but it doesn't cause an overflow. Types in some years, that's a big humongous number of years, but doesn't cause an overflow. This works, it calls calculate future value. And so as it's looping, let's say you put in 1,000,000 months or something, it's looping away, adding, multiplying, adding, multiplying, adding, multiply, and then this future value number just gets too big, and it overflows. The number's too big, so that causes an exception. That would be caught here. That would be caught back up here. Okay, so the exception was thrown down in here in this calculate future value. It comes out, bounces out. It's not a format exception because everything was formatted properly, but it was an overflow exception. So it gets caught there. Code that checks that an entry has been made. So it's possible that the person does not type anything in. Checks a valid decimal value. Okay, we're getting into data validation now, aren't we? Okay, so this is all the data validation stuff, and you know, this is really how you want to do it. When you're in production, you know, you're writing code that's gonna be used by average users that don't know anything. You know, your messages should be very explicit, and considering what, you know, the knowledge of your user, the assumptions about the knowledge of the user. Okay, here is the idea is you will write these little methods here that will actually check the range of things, and then you use these little methods that you've written to check the range of things, and you know, this code checks the validity of an entry. First of all, you want to make sure that the monthly investment is there. You want to make sure the user actually types something in. That would be is present, is decimal, is within range. So we've got is present. So this just checks if it's there. Okay, if it's there, it's fine. This checks if it's a valid decimal value. You know, if the guy just types in blah, 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 FU, that passes this one, not a problem. But it's not going to pass this one because the guy didn't type in digits. And so this is how you would check that. You know that. Let's try parse. And it would return this error message. And then let's say you want to restrict the range. You know, you don't want somebody fooling around being stupid. So you say, okay, no, don't make your monthly investment less than 0. Come on, don't be dumb. And don't make your monthly investment greater than $1,000. Nobody's going to do that. Maybe, I don't know. So it's a range. So yeah, what is the difference between this and this? Oh, it's just a required field. This is a method that checks to see if it's a valid numeric number. Oh, so here we're actually defining these methods now. Is present is a method that this is a little method that we're gonna write that uses this checking to see if somebody types something in. So it's a method in and of itself. It takes a text box value. It actually takes the text box object, and we're going to call it text box. So in here we put the name of the object, and then string name. So this is the name of the text box, I guess. Numeric value. This checks the valid range, and then this checks the value of the validity of the entry. So this little method that you write takes the control. It's TXT monthly investment is a text box that's on your form. So it takes that, so it treats it like a text box, and we're calling it text box. No matter what you call it up on the form, in this little method we're going to call it text box, and here we take the text property of the text box. So inside here we're going to call it text box, but out on the outside we call it TXT monthly investment, because that's what you named it. That's what you named your control. That's what you named the actual text box on the form. See that? So this if statement checks the validity of an entry. First, it's gonna check the validity of the entry into the TXT monthly investment text box on the form. So this first thing is this is present method has got to return true. You know, this thing returns true or false. Yeah. This is method is present has got to return a true, and is decimal has got to return a true, and is within range has got to return a true. They all have to be true. There's ampersands here. And if they're all true, then it's going to execute this if block, which is simply a message box which says, hey, good job. You know how to type. It's telling me to stand up. Okay, so this is data validation. We're going to actually cover this more later. This is how you do it for the feature value application. And simple calculator, that's what we're going to do. This is our assignment, simple calculator. So it's the same thing for simple calculator. All right, so let's take a peek at that real quick, and then we'll quit. So if you look at assignments for today, if you look at this one, assignment 5, exception handling. First, I want you to take the simple calculator that you created in assignment 4, and I want you to throw in some more exceptions here. I want you to add, I tell you specifically what to do, add a try catch to do all these exceptions. Okay, so that's part 1, and that's great. You're going to do it for using exceptions. And then part 2, I want you to go back and take the simple calculator again that you created in assignment 4. Not the one from part 1, because part 1 uses exceptions. Part 2 is going to use data validation instead. So you don't want to have exception handling in part 2, except for you want to have a general overall exception handling thing at the end, just in case, or because it's possible that it's quite possible that you don't cover all the exceptions that can occur, but you cover the majority of them. There's other exceptions that can occur that are beyond your control, like the printer is out of paper. You know, your program is running along and the printer's out of paper, and all of a sudden this exception occurs, and you you know, you wanted it to die. Yeah, that's just an example. So you're doing the same thing. You're accomplishing the same thing in part 2, except for you're using data validation instead of exceptions. And we can talk more about this next time, and we'll dive into the code a little bit and write some of it for you, and you know, for you to finish. All right, does that make sense? Are there any questions? All right, so I will see you, this is Thursday, I'll see you Tuesday. Thanks for watching.